Assalamualaikum and hi. So in this lab lecture, which is practical 3, we have done batch culture of Nannochloropsis species. Culture is a process of culturing algae. The purpose of culturing algae is to see the growth of the algae. Doing the algae culture, we have to maintain the culture parameters, which is the temperature and light intensity. As you can see from this graph, usually we are going to harvest the algae before the death phase, so that we can know the density of the algae. A mass cytometer is an apparatus used for counting microalgae cells. The diameter of this mass cytometer is ranged up to from 2 to 30 micron, and the density is up to 500 million cells per ml. So each area from a chamber 0.1 mm deep, and the total area of each chamber is 9 mm square. So this is mass cytometer we use. In this mass cytometer, we have two chambers, one is here and one is here. So in one chamber, we have 9 millimeter square. So the length is 3 times 3. Each of the square is 1 millimeter. So we are going to count the microalgae from in this 4 small box here. So it's not that we are going to count all of the 16 square, but we are just choose 3 of the small squares inside. We have 12 small boxes. Yeah. So this is medium we use for culturing algae. We use 2 medium, which is F2 and Wallner medium. So this is taxonomy classification for our microalgae that we use, which is Nannochloropsis. So Nannochloropsis are from the kingdom Chromista under phylum Ochrophyta, the class of Eustigmatophyceae, order Eustigmatales, family Monodocsidaceae, and the genus of Chloropsis. So the objective of our experiment, it's to do a small scale batch culture of the same microalga in different culture, which is F2 and Wallner, to compare the growth phases of the microalga by observing its morphology, size, color, and density from start until harvest, to compare alga growth rate, division time, and yield as fresh weight and dry weight per unit. Yeah, that's all for me. Thank you.
The working area and the apparatus were sterile by using ethanol. Then, the apparatus will flame over the present burner to prevent airborne microbe. The mouth of the volumetric flux stack containing Wallner media will flame. 110 ml of Wallner media were measured and poured into a conical flask. The mouth of the flux stack containing Nannochloropsis was sterile and flamed. 70 ml of the Nannochloropsis species were measured and transferred into the conical flask that contained the Wallner media. The media were mixed and flamed. Aluminium foil were used to wrap the mouth of the flask and autoclave by using paraffin. The steps were repeated for replicate 2. Then, the steps also repeated by replacing 2 F2 media for replicate 1 and 2. All the flasks were placed in an aerator machine.
So this is the methodology for harvesting. First, we do the pre-combust. We fold the aluminium into a pocket and according to the media and replication. After that, we insert the filter paper in the pocket of aluminium foil and then put it in an oven for about 1 hour. After 1 hour, we will place in a desiccator for overnight. On the next day, we will weigh the filter paper. And the microalgae culture was transferred in a measuring cylinder for 15 milliliter. We put the weighed filter paper on a filter pump and pour the measured 15 ml of microalgae culture in the filter pump. After that, we put back the filter paper in an aluminium foil and place in an oven for 1 hour. After 1 hour, we will put in a desiccator for overnight. On the next day, we will weigh the filter paper for at least 3 times to get an average weight of the filter paper, so that we will get the dry weight for the algae.
So I will be presenting result. So this is cell density of Nannochloropsis sp, showing the graph for walnut culture media in walnut 1, walnut 2, F21 and F22. Okay, let's remove to figure 17. So we take a look at walnut 1. So this part that I have circled, this shows the log phase of the Nannochloropsis sp in culture media walnut 1. It takes from day 4 to day 5. So this is the growth rate calculation after being calculated. So this one is for F22, and then okay, this is a special case. We have a fluctuated graph here. Okay, then this is a growth rate calculation according to the Velasco et al. 2016. The specific growth rate K was calculated by using the formula initiated by Fogg 1965. So these are the 3 growth rate that's been calculated. This is a dry weight. So how to calculate the dry weight? We use the weight of filter paper plus algae that has been filtered minus the weight of filter paper pre-combusted, and then we move to division time calculation. So how to calculate the division time calculation? We use the formula constant, which is 0.6931 divided by growth rate. So for example, division time for culture media in walnut 1, we took the constant 0.6931 divided by growth rate of walnut 1, growth rate of culture media, which is Nannochloropsis in walnut 1, 1.4429, resulting 0.4804, and then we will follow by F22 and walnut 2. Okay, this table 2 shows the color intensity of Nannochloropsis sp by our group. So we managed to finish our experiment for about 7 days, and then day by day our Nannochloropsis sp color in the culture media getting paler. That means decreasing in number of the microalgae.
Morphology of Nannochloropsis unicellular eukaryotic marine microalgae consists of 6 species. The shape is slightly ovoid and spherical, lack of flagella. The color is green. Color intensity. The color intensity of F2 medium changed from green to cloudy brownish color according to table 2 due to the going through the dead fish and the presence of zooplankton. The color intensity of walnut medium is more intense compared to F2 medium due to the lack of zooplankton.
The cell density was the highest in walnut medium as compared to F2 medium. There are a few nutrients that help with the growth of the algae. The graph fluctuates due to existence of zooplankton. This is due to contamination during preparing the Nannochloropsis species culture. Human errors such as didn't sterilize the apparatus used properly, and counting the clumped cells should be avoided. On day 6 and 7, Nannochloropsis species in F22 and walnut 1 culture die due to presence of zooplankton and insufficient nutrient. The fastest growth rate recorded was in F2 medium as compared to walnut medium. Light intensity is not the main factor in changes of growth rate, but temperature is the main factor. For F22, the light intensity range is quite low, but the growth rate recorded was high. There's difference in growth rate value due to various methods of clustering, light intensity, and temperature. Our batch culture, which is in the range of 27.7 to 31.3 degrees Celsius, is not within the optimum range. The optimum temperature range for growth rate and biomass is between 20 to 25 degrees Celsius.
Okay, for growth rate and division time, for F2 medium, the division time is faster compared to walnut medium. Within the short period, it was observed growth rate of F2 medium is high because the division time is low, meaning that within the short period, the cell divide rapidly causing the growth rate to increase. For biomass, growth rate is related to biomass. If the growth rate is high, biomass will also be high. Based on figure 20, F2 has the highest value for the dry weight and growth rate, which means that F2 is the favorable medium for Nannochloropsis species. But according to the previous study, the algae growth is optimal in the walnut culture medium as compared to the F2 culture medium. This is because walnut culture medium has nitrogen in its composition that is lacking in other culture medium. Nitrogen is important in the making of chlorophyll molecules and cellular protein, which is crucial for the growth of microalgae cells. Besides, ammonium concentration in walnut culture medium is 150 times higher than F2 medium. Ammonia is needed for algae growth, and algae prefer ammonia as compared to nitrate because less energy is needed to consume ammonia as compared to nitrate. Based on our result, Nannochloropsis species is positively grow on walnut medium compared to F2 medium. This is because walnut medium has enriched nutrient that enable for microalgae to grow. According to Shah et al. 2013, Nannochloropsis species is a suitable food for zooplankton, larvae of fish, and crustaceans. One of the study from Malakotian et al. 2019 said one of the usage of Nannochloropsis species is as biodiesel production. Apart from that, physical parameters such as pH should be taken, as microalgae are very sensitive to pH changes and can affect their growth rate. In the future, the experiment can be improvised by reducing the human error. A proper method to count the cells should be applied, and make sure to sterilize the apparatus used to avoid zooplankton contamination.